What if we can replace fossil energy with an alternative energy that is clean and sustainable? This world will definitely be a better place. Fossil fuel as an energy has led to many problems. For one, it led to depletion of its supply. And secondly, it has high impact on our environment. Because this energy is not sustainable, we know that it's gonna run out soon. And it is predicted that by the year 2050, its reserves, the oil and gas, will be 70 to 75% than it is in 1997. In addition, carbon dioxide emission has been causing serious environmental problems, such as in this data, it shows that in 1750, it started where the industrial period started, and then it has been increasing until 2007. Thus, we are needing another alternative energy than fossil fuel, and renewable sources are a lot. But we are looking at one particular energy, and that is hydrogen energy. The reason is, for one, it is clean. In its combustion, there is no carbon dioxide formed. And secondly, it is potentially sustainable. So this can be explained by its cycle, the hydrogen cycle. So in this, we can see that hydrogen can be produced from water using sunlight with some catalysts, and it can be stored on demand, in which you can also access it to be used in fossil fuels and other applications, and these will produce water, which will then be starting the cycle again. Now, one of the main challenges of this application is storage, because hydrogen gas at room temperature and pressure where we are now is moving around, and it takes up a lot of space. So for example, if you would like to drive your car from here to Canberra and back, that's about 300 miles, it takes 5 kilograms of hydrogen, and that fills up the volume of 60 cubic meters, or about 3 to 4 times the volume of your car. So you can imagine that your fuel tank will be larger than your car. So in my PhD, I'm developing materials that can hold on to hydrogen so they can't move around, thus can fit the same amount of hydrogen in a concentrated smaller space. We call this solid-state hydrogen storage materials. So they react with hydrogen by acting like a sponge, either physically or chemically. Physically means the HH bond of hydrogen does not break, but they actually extend so that it can react to the substrate of my material. While chemically means HH bond breaks and H is integrated into my material. However, for this application, there is still no ideal solid-state material that is used for hydrogen storage commercially. So in my study, I'm exploring porous silicon materials for hydrogen storage because it has remarkable internal surface area in which hydrogen can be stored in this porous structure. Also, there has been studies here in UNSW that showed promising results, but we need to investigate it better. Also, there is little knowledge about the hydrogen bonding with my material and hydrogen. So in my study, I'm focusing on 2 things. The first one is to fabricate and also to develop these materials in 2 forms, porous silicon powder and porous silicon thin film. And also, secondly, I would like to understand and look at how hydrogen interacts with these materials so that one day we will continue to make progress and we'll find a material that is ideal for hydrogen storage commercial applications, and then we'll all be driving cars powered by hydrogen and not by gasoline. Thank you.